Recall that to find the area of a triangle, we use the formula area equals 1/2 base times height. So if I look at my triangle, this would be my base. So if I count that off, I get the base is 5. And my height, I can count right along that horizontal line, and I get 6. So then that's half of 30, which is 15, which was C. Now we have the area of a rhombus. Well, the formula for the area of a rhombus is 1/2 D1 times D2. And again, I can just count along that length to find the diagonal 1, which is 4. Diagonal 2 is going to be this horizontal length, which is 6. So I would do half of 24, which would end up being 12. So that's B. For number 3, you're trying to find the perimeter. So you can find this missing side by adding the 6 and the 2, which is 8. And you can find this missing side by adding the 10, or not adding, but subtracting the 10 and the 5, and getting that side as 5. And now if you'll just go around and add up your lengths, you'll see that that should add up to a total of 36 feet. Now we want to find the area. So I do this one by thinking of this as a rectangle, a big rectangle, minus a little rectangle. Well, the big rectangle is 13 by 7, and the little rectangle is going to be 4 by, to find that distance, we can take this whole distance of 13 and subtract out the 5 and the 2, which is 7, and get that that's 6. So that gives me an area of 4 by 6. So we're going to get 91 minus 24. And that should give us an answer of 67. We're now to another kite problem. And our formula for the area of a kite is D1 times D2. 1/2 D1 times D2. There's diagonal 1, it's 16. Diagonal 2 is this distance, which is a total of 21. And so if I do 1/2 of 16 times 21, we should end up with 168. Now we're looking at a composite shape. There's several ways you can do this. I actually did this one as treating it as a rectangle and a trapezoid. So I divided it up that way. That way I knew that the rectangle here is 5 by 8, so that's got an area of 40. And then my formula for a trapezoid is 1/2 base times height. No, let me get that right. The area of a trapezoid, that was the area of a triangle. The area of a trapezoid is 1/2 H B1 plus B2. But then I know the height of my trapezoid is here. That's going to have to be 4 since this total distance is 12 and we've got a side here of 8. So then my height of my trapezoid is 4. And then my two bases are this distance, which is 7, plus this distance, which is 5. And so that's going to end up giving me 24. And then when I add those two together, I get 64. In this problem, we're trying to figure out what is the total area of the parking lot. So that's this area out in here. So again, it's similar to the one we just did. I'm going to treat this as a big rectangle minus the smaller rectangle. The big rectangle is 75 by 90. So I'm going to take 75 times 90. Then I'm going to subtract out this little rectangle, which we know is 25 by, and then we're going to have to figure this out. But we can do that by taking 90 minus 20 and 20. So that makes that 50. So if we do 75 times 90, we get 6,750 minus 25 times 50, which is 1250. We get 5,500, which is C. In number 8, we're trying to find the perimeter of the square, and we know that the radius of the circle is 6. Well, if that is 6, that means the whole square has a side of 12. And to get the perimeter, I would just do 12 times 4, which is 48. On the next problem, we have that a rectangle and a parallelogram have the same area, and they want to find the value of x. So the first thing you want to do is find the area of that parallelogram, which is base times height. The base of the parallelogram is 14, and its height is 9. So that gives me an area of 126. But then that means this area has to also be 126. So I want 12 times x to equal 126. And that gives me 10.5. In our next problem, we have multiple steps here. So the first thing is, what's the total length and total width of the park? So you've got a garden, and they've added a 36-inch walkway all the way around it, or a sidewalk. Well, I'm going to need to change that to feet because everything else is measured in feet. So luckily, 36 inches is 3 feet. So to find the total length of the park, I would want to find this whole distance, which is 24 plus the extra 3 feet on each side. So that's going to make my new length be a total of 30. And then I do something similar to find the width. I'm going to use this width, which I know is 8, but then I've added 3 feet on each side, so that makes my new width 14. So what's the perimeter of the park? Well, then I want to add 30 plus 30, and then 14 plus 14. So that's going to give me 88 feet. And both of these were also in feet. And then what's the area of the sidewalk? Well, now that's going to be one of those composite shapes where I want to take the big area minus the little area. So if I take the total length, which was 30, times the total width, which was 14, minus the area of the rose garden, which was 8 by 24, I'm going to get 420 minus 192. And that gives me 228 square feet. For problem 11, we have multiple parts. So we're making a doormat that's in the shape of a semicircle, and we have two parts to it. We've got this interior part, and then we've got a border. So question A says, what is the radius of the rough fiber interior? So notice that they tell me that the diameter is 28 inches, so that's going to make my radius be 14 inches. And then they ask for what's the radius of the entire doormat. Well, now we're looking for the distance all the way out to the edge, which is going to be 14 for the rough interior and the extra 4. So that would make my radius 18 inches. Now it wants to know the area of the rough interior. Well, we can do 1/2 pi r squared because we're doing half of a circle. So that would be 1/2 pi. And the radius of the interior we said was 14. So now if we just do 1/2 of pi times the radius squared, we get 307.9. And that would be square inches because we found area. And then we want to know the area of the border. So now we're doing the area between the two semicircles. So I'm going to do 1/2 pi big radius squared minus 1/2 pi little radius squared. Well, the big radius was the radius of the entire doormat, and we said that was 18. And then I'm going to do 1/2 pi. My radius of my inside was only 14. So we just put that into our calculators now. And I get 201.1. And that would be square inches again. So we're looking at a composite shape here where we're going to add a rectangle plus half the circle. So we know that we want length times width plus 1/2 pi r squared. Well, my length and width are 20 and 30. And my radius would be half of the width of the rectangle, which is 10. And now if I do 600 plus, that should end up being 157. That's going to give me 757 for my area. All right, in the next problem, we're looking for the area of a trapezoid. Well, we know our formula for the area of a trapezoid is 1/2 h B1 plus B2. We know our bases are 6 and 12, but we don't know our height. So we're going to need to solve that. So I'm going to pull off this little triangle on the corner where that's a 5. And I can figure out, because it's an isosceles trapezoid, that has to be 6. If the total length is 12, then that means the other two segments together have to make 6, which makes them 3 meters apiece. So now I know this is height is going to have to be 4. And now I can substitute into my formula. I want half of 4 times 18, which is going to give me 36. In this problem, we're looking for the measure of the central angle when we know the arc length. So recall that our formula for arc length is m over 360 times the circumference, because arc length is part of the circumference, so that would be 2 pi r. Well, the arc length is 20.42, and I know my radius is 10. So I'm going to clean this up a little bit and get 20.42 equals m over 360 times, and I'll go ahead and put the 2 and the 10 together and get 20 pi. Now you could go ahead and simplify the 20 and the 360 and reduce that. I know most of you probably wouldn't do that, so I'm going to go ahead and multiply by 360, and that'll eliminate that fraction for me. So if I take 20.42 and multiply by 360, I get 7351.2, and that equals 20 pi times m. But then I'm going to divide both sides by 20 pi to get m by itself. So if I take 7351.2 and divide by 20 pi, I get 116.99, which tells me that my angle is about 117 degrees. Now we want to find the area of this triangle that we have here. This is a simple 1/2 base times height. If you know your Pythagorean triples again. So since this base here is 10, it splits into 5 and 5, and now I can see that I have a right